Images of the discoveries made by NASA on Jupiter, discoveries at the Great Red Spot, fresh perspectives on a planet's moon, and more. Allow us to demonstrate what NASA found on Jupiter in real photographs. Intro roll. It is simple to understand why Jupiter is of interest to so many individuals at NASA and elsewhere. It is the largest planet in our solar system, a gigantic gas giant with a wide variety of unusual atmospheric features, and it has so many moons that any one of them might contain important discoveries that we wouldn't know about until we genuinely conducted a thorough search on them. For this reason, we have attempted to make passes at Jupiter in a variety of methods over the years in order to obtain not only images, videos, and even audio recordings of the planet, but also to gain a better understanding of how this planet functions as a whole. Introducing the Juno probe. Since its launch in 2011, it has been providing NASA and others with a wealth of Jupiter-related data. Even now, 10 years after it was first introduced, it is still giving people useful information, like some recent fresh discoveries. For instance, if you've ever taken the time to look closely at Jupiter, you've probably noticed a great red spot that is clearly visible to everyone. That has piqued the interest of scientists everywhere, and as a result, Juno was dispatched to investigate it whenever it was feasible. As a result, fresh findings have altered our previous understanding of it. According to Scott Bolton, principal scientist of NASA's Juno mission and director of the Space Science and Engineering Division at the Southwest Research Institute in San Antonio, the Great Red Spot was once assumed to be a storm with the shape of a flat pancake. Although we were aware of how long it lasted, we were unaware of how deep or effective it was. The Great Red Spot is around 10,000 miles, 16,000 kilometers wide, and in February and July 2019, NASA's Juno probe sailed directly over it to measure its depth beyond the apparent cloud tops. One of the team's experts stated the following: "The level of accuracy needed to determine the Great Red Spot's gravity during the flyby in July 2019 is astounding. The fact that we can confirm the depth findings of the microwave radiometer gives us tremendous confidence that the results of future gravity tests at Jupiter will be similarly fascinating." Now, some additional things can be said about it based on the facts discovered. Juno's microwave radiometer led researchers to view the planet in 3 dimensions. They found that the Great Red Spot extends far farther into the gas giant than they had anticipated, ranging in depth from 124 miles, 200 kilometers, to 311 miles, 500 kilometers. According to Marzia Parisi, a research scientist at the NASA Jet Propulsion Laboratory, the Great Red Spot is as deep into Jupiter as the International Space Station is high above our heads. The size of the patch is getting smaller as the storm intensifies. Its diameter was double that of Earth in 1979. The area has decreased by at least a third since then. Many are left to speculate about what may happen in the future. Will it keep becoming smaller? Will its size suddenly increase again? It's difficult to say. We do, however, know that Juno will monitor it and provide updates as often as it can. And the planet is not the only thing it has been examining. In order to take pictures and understand more about Jupiter's poles 5 years ago, researchers used information obtained by Juno. Juno discovered that the gas giant has 8 cyclonic storms forming an octagon at the North Pole and 5 pentagonal-shaped cyclonic storms at the South Pole. But this is where things start to get pretty weird. Mostly due to the storm's lack of motion. They are firmly planted there. The cyclones on top of each pole pushed back as the polar cyclones displayed patterns of trying to go nearer the poles. Because of this, it is clear why the storms have stayed put. That kind of storm, one that physically pushes against another to keep itself held in place, is clearly not the kind you'd expect to see on a planet. Additionally, the number of storms at the poles says a lot. Another example of why it's important to research what's happening at the poles and how it affects the rest of the planet. Please let us know whether you liked the video or not before we proceed to show you what else Juno has discovered so that we can keep producing the greatest material for you, the viewer. Be sure to follow the channel as well. Now let's return to Jupiter. Focusing on the atmosphere will help us better understand the clouds that are present there, because they might not behave precisely as you would expect or be exactly what you imagine. The east and west jet streams are 200 miles, 322 kilometers deep, and they contain Jupiter's clouds, according to Karen Dewar, a doctorate student at the Weizmann Institute of Science in Israel. Ammonia was tracked by the research team as it moved, and it was discovered that it moved north to south and up and down around the jet streams. You might be surprised to learn that Earth has comparable cells out there. They are known as feral cells, and they aid in regulating our planet's wind and other circulation patterns. This then helps to control our planet's climate in ways that assist us produce the right amount of heat. However, with Jupiter, they are significantly bigger, more frequent, and have a greater overall impact. This indicates that Jupiter's cells are at least 30 times deeper than their equivalents on Earth, according to Dewar. There's a lot to delve into with that alone, not the least of which is that the Juno probe is demonstrating just how crucial it is to the study of Jupiter, since it can look beyond what many can do here on Earth and provide much more detail about what's happening with the planet. Southwest Research Institute, SWRI, in San Antonio's Scott Bolton, the Juno project's chief investigator, said, "We were previously taken aback by Juno's signals that certain processes occurred deeper in Jupiter's atmosphere than we had anticipated. Currently, we're beginning to put all these disparate parts together and gaining our first thorough grasp of how Jupiter's stunning and violent atmosphere functions in 3 dimensions." And to be clear, he truly does mean violent, because Jupiter is experiencing other phenomena in addition to the Great Red Spot and the polar storms. Jupiter is home to both cyclones, which move in a clockwise direction, and anticyclones, which move in a counterclockwise direction. According to Juno, cyclones feature warmer air at the top with lower density and cooler air with more density at the bottom. The converse is true with anticyclones, which have colder air on top of warmer air. They are therefore polar opposites of one another, which makes it even more remarkable that Jupiter doesn't just happen, but that they appear to occur in large quantities. Another justification to continue investigating Jupiter to see what we can learn. Let's speak about the auroras that are visible on Jupiter while we're still discussing what's happening in the atmosphere. It comes as no surprise that they resemble those on Earth pretty closely. With one significant exception, of course. Consequently, the ones on Jupiter are very much more potent than ours. Just how much more potent? The ones that we are aware of, however, are rumored to be so powerfully supercharged that they are capable of going and temporarily electrifying every city inhabited by humans. A lot of power, that. But the mystery is more complicated than that. Because scientists are unsure exactly how these auroras are generated, despite the fact that we know they originate near the planet's poles. They postulate that this is caused by Jupiter's atmospheric conditions, which they say force supercharged particles to be released, which then clash to produce the aforementioned aurora. The necessity for additional research on these beings is unquestionable, especially if it means learning more about our planet's auroras and improving our ability to study them. Of course, the moons are just as important to study as the planet itself. Finally, we have a clear image of Europa's North Pole, at least when viewed from a distance. The picture was captured by Juno as it was carrying out its main task, which was to study Jupiter's atmosphere from a distance of about 50,000 miles. Scott Bolton, the principal investigator on Juno, said that the view will be better when the spacecraft passes only a few hundred miles over that same spot next year. This is a tantalizing example and a taste of what to come. Popular travel destination Europa has been photographed numerous times by spacecraft. The frozen surface was first seen up close in the 1970s from NASA's Twin Pioneer and Twin Voyager probes, which both had identical twins. The Galileo mission, which orbited Jupiter and its moons between 1995 and 2003, provided even more detail. As you can see, NASA scientists have benefited much from the Juno probe over the years. so it shouldn't come as a huge surprise that they've extended the mission of the Juno probe until 2025. The scientific community can benefit greatly from the additional information on Jupiter that will be available in about 4 years. However, some people may not perceive the relevance of this. Why should we travel and study Jupiter in such detail? Why should we be concerned with the Great Red Spot, these anticyclones, or the appearance of one of their moon's north poles? Why should we even be concerned about that? The more knowledge we have about the Earth, the more we can envision what we can do with it in the future, is the answer. Exploring the stars and colonizing other planets and moons has long been the aim of humanity. And while Jupiter itself might not be a friendly place for people to go and dwell because, as far as we can determine, it doesn't have a ground, it does have a lot of moons, many of which have been thought to be prospective landing spots for humanity. However, given that, Jupiter would still be extremely close to us. Understanding the planet's characteristics, its true composition, and how its fields and atmosphere affect the adjacent moons is crucial. We'll be in big danger if we don't understand these fundamental concepts, and nobody wants that, right? But just as significant is the fact that the more we research this gas giant, the better chance we have of understanding future gas giants, not only those in our solar system, but also those we observe from space. As we enlarge our field of vision, extend our reach, and seek out new gas giants, it is essential to be aware of what is nearby. We can then adjust and fine-tune our ideas as we proceed because we'll have a foundational idea of what is out there. It's also enjoyable. We actually use the Juno probe as our eyes and ears in space, and without it, we wouldn't know even a fraction of what we do now about Jupiter. Why then do you think I should go study Jupiter more? Why not is a better question to ask. Thank you everybody for watching. What did you think of this look at Jupiter and all the new discoveries made there by the Juno probe? Do you believe that we will learn more about the largest planet in our solar system as a result of these discoveries? Do you believe there is still more there waiting to be discovered and uncovered? Please let us know in the comments section below, and we'll see you on the channel again soon.